The second continuous random variable probability distribution we're going to look at is called F distribution. Now F distribution has a shape like this, and it is in the first quadrant, meaning the X values will have to be non-negative, 0 or more. Alright, and the random variable that follows F distribution is of this particular characteristic. Okay, it is a ratio of two sums of squares. Okay, in other words, we can think of it as ratio of two variances. Okay, variance of one variable divided by variance of another variable. So that would be a ratio of sum of squares, and that will follow an F distribution like that. Okay, and because it is sums of squares both in the numerator and the denominator, sums of squares cannot be negative, and therefore the values are always positive. And the required parameters for finding probabilities or using the F distribution are: you either have to have F value. If you have the F value, which is the ratio of two variances or two sums of squares, then you will have two degrees of freedom. The df sub 1 is the degrees of freedom associated with the sum of squares in the numerator. Remember, it's a ratio of sum of squares. Then df sub 2 is the degrees of freedom associated with the variance in the denominator. Okay. Then with f, df sub 1 and df sub 2, you can find the probability corresponding with that f, which is again a cumulative probability. So it should be like that. Actually, there is a you can find the inverse cumulative, that is the tail area. Okay. The Excel has a function with dot RT, right side probability. We will see that in just a second. Or if you're given a probability, if you're given that tail area, we can find what the f is. So you need to have either the tail area, which often is referred to as alpha. So if you have the alpha and df sub 1, df sub 2, we can find f. Now if you have the f and then df sub 1 and df sub 2, then we can find the probability. Okay, let's look at an example. Okay. And we'll be using this in regression and some other concepts that we'll be covering in later chapters. Okay. Suppose we have an f value of 4.39. Okay. And the degrees of freedom of numerator is 5, degrees of freedom for the denominator is 6. Okay. This, right now there may be some, you may wonder what is this numerator degrees of freedom is, what is degrees of freedom is, but we'll look at an example, more concrete example in regression. Then I'll remind you at that time that this is what we did back in chapter 2. Okay, so if you have the f value and the two corresponding degrees of freedoms, then we can find the right side tail probability using, see, there is two functions. Okay, f dot dist will give you the cumulative probability. Very often when we're using F distribution, we will be interested in the tail area. That's the reason why Excel gives you the tail function as well. So we'll use the tail function f dot dist dot rt. Rt stands for the right side. Then x, that's your f value, and then the 2 degrees of freedoms. Okay, so this will give you the tail probability, which is that. Okay. Or if you're given alpha, okay, suppose if the tail probability is given as 5%, okay, and the degrees of freedoms are 5 and 6, then we use f dot inv. Again, we have two versions of this function. F dot inv, if you use f dot inv, then you have to provide cumulative probability for the function. But if you use f dot inv dot rt, then you have to give the parameter that you need to provide is the tail area. So that's the tail area. Okay, and comma the 2 degrees of freedoms. So that will give you the f table value. Okay, this is the inverse function.